Okay, so here we are at standard ETM.2. I can find and use kinetic energy and gravitational potential energy for an object. So this is question B on the quiz May 23rd, 2019. The person is 1.5 meters above the ground at position Z. So I've drawn that here. H equals 1.5 meters. What is the person's gravitational interaction or gravitational potential energy here? So if you look at your MCAS sheet, which you should do, the best equation that you're going to find for this is this one, the impulse equation. So delta PE, or the change in potential energy, equals mass times gravity times the change in height. Now, just change that, because we're not talking about anything changing at this point. Just take the deltas out, call PE gravitational potential energy. It could be other kinds of potential energy, but not in this case. Equals mass times gravity times height. All right. So once you start there, this is an easy question to solve. So the unknown thing is already isolated. So we've already solved for the thing that we want, and we can just plug and chug. What is the person's mass? It says all the way up above that the person is 70 kilograms. So that's going to be 70. When I'm diagramming equations like this, I usually just leave out the units. I'll put those back in, don't worry, later. Gravity is 10 meters per second squared. 9.8 would be fine, 9.81 would be fine, but don't make it too hard on yourself. 10 is a perfectly good number for our purposes here. And we were given the height. Height is 1.5 meters. So we were given the height 1.5. And you multiply all those numbers out. 70 times 10 is 700 times 1.5 equals 1,050 joules. That's it. That is the answer, and that is how to solve that problem. We'll need this information to go on and do a slightly more complicated problem next in question C.